Good morning, students. Students, we are studying the chapter Forces and Laws of Motion. Based on the previous classes, I think now you have a superficial idea about the force by the effects it produces in different bodies, like changing the direction, shape, and accelerating a body. That means changing the state of rest to motion of any particular body. So knowing that the force can produce such a huge amount of effects on different bodies, it is being applied and has a various kinds of applications in most of the areas of human life. Like if we say we have to construct a dam on the river bank, a particular amount of load is required and a particular amount of knowledge of the force and the pressure which is acting by the water on the walls of the dam is required. Similarly, if you have to construct a road, what amount of force a roller should apply on the particular road while rolling or smoothing the road, so it requires knowledge of force. Similarly, if you have to print the newspaper or we have to assemble the machine parts of different machines, suppose we have to construct a turbine or a boiler for a thermal power plant, it requires the knowledge of force. So there are many more applications of the force which should be studied properly, and we should have a basic idea about how to represent the force. So what is the representation of a force? So actually students, the representation of force means how we are going to represent it in the form of its magnitude and direction. So as we know, the force is a vector quantity, so it has both the magnitude and the direction. So students, a force is represented by an arrow. So first of all, you can see this is a block on which a person is applying force in this direction. Okay, students. So this point will be named as the point of application of force, where the hand is in contact with the wood. This point at which the hand and the block is in contact, that point will be named as the point of application of the force. Okay, and if with this from this point, if we draw a particular straight line towards in this direction, as the force by the hand is acting in this direction, so if we apply or draw a particular line from this point straight away in this direction, that will be the direction of that particular force. Okay, so the line drawn to the point of application of the force in the direction of the force is called the line of application of force. So this is the line of application of force, students. Okay, so uh, to represent a force, we should know its magnitude and direction. So this line, suppose this is a line of 10 Newton, that means uh, 1 centimeter is equal to 2 Newton. Okay, so the 5 centimeter line indicates that it is a force of 10 Newton, and the arrow pointing in this direction will represent the direction of the particular force. As in this case of the block in the hand, the arrow is in this direction, so the person is applying force in this direction. It might be near I should say it should be near west north. Okay, so similarly, this length is the magnitude of the force, and this arrow is pointing the direction of the particular force, and this point is a point of application of force, and this line is the line of action of the force. So students, now we understand how to represent a force. Force can be classified into contact forces as well as the action at a distance force. So students, simply we can understand from the term contact that a force that is exerted when the two bodies are in contact. Suppose we can say in the various figures, this person is in contact with the wooden table and he's pushing this wooden table towards in this direction. So his body is in contact with the wooden table, so he's pushing it in this direction. That means it is a contact force. Okay, even there is a frictional force which is acting on this table from the floor, so there is a contact between the table as well as the floor, so there is a contact force. In every case here, there is a contact force on this wooden table, without which this wooden table can't be in motion. Similarly, this child is pulling the water from the well, so there is a tension force which is acting on the rope, and this rope is in contact with that child. So this child is holding this rope, so there is a contact force which is acting on the rope, and correspondingly to the bucket which he is drawing from the well. Similarly, this woman has bought some vegetables from the mall or the shopping market. So he is applying a force on this trolley. In this way, there is a contact force between this woman and this trolley. Similarly, this child is running, and behind this, his friend is running, he's chasing him. So this bicycle is in contact with the floor, and even that person is applying force on the paddles so that the bicycle should move. So this is a contact force which is being applied by the this person on the bicycle, as well as the bicycle is being applying a force on the floor because of this contact between the bicycle tire and the floor. And there's also a friction force which is acting towards in the backward direction because of this contact between the bicycle and the floor. And this child is running, so he's pushing the floor backwards, so there is a friction force back in the backward direction and a reaction force in the forward direction. In this way, this is based on the Newton's third law. So this child is able to move and run on this ground. Now students, there are certain kind of forces which act from a particular distance and act through the space between the two objects. So there are various forces, like as we know, the Newton's law of gravitation states that in any heavenly body attracts every other heavenly body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So in this case, students, the sun is a heavenly body which is attracting different planets towards him, because there is a force which is acting between every planet as well as the sun and the planet. So this can be considered as an action at a distance force. Similarly, when we rub our comb on our hair and try to attract the straw or the wrappers of the paper, it gets attracted towards it because the comb is being charged as well as the wrappers of the papers are being charged. So there is a opposite charges attract each other. In this way, the positive and negative charges will attract each other, and this is the example of an static electricity. So this is also an action at a distance force. Similarly, the magnet can attract the bearings because the bearings may be of iron bearings. So the magnet is attracting the bearings because the magnet has a certain magnetic field around it, because of which the magnetic material, that is iron, is being attracted towards the magnet, towards the north and the south pole of the magnet. And even we know about the gravitational force, the pull of the earth. Because of the pull of the earth, because of the gravity, the apple falls towards the earth's surface. Okay, so this is also an action at a distance force because the earth's center is attracting the apples or any other thing which is being thrown upwards in the sky towards the earth's surface. That is the action of gravity. Okay, so you all have experienced this gravity in your day-to-day activities in life. Okay, so in this way, students, we understand the representation of force, which can be represented by a line which shows the magnitude and the direction of that particular force, and even we can represent the force by it can be a contact force, and it can be a action at distance force. So contact means when the two bodies are in contact, that force is when considered as a contact force. So in every example in this case, you can see there is a contact between the body and the person who is driving their particular force. Now in an action at a distance force, the thing or the body which is attracting the other body is at a distance from that particular body, and from the space there is a certain kind of field or a magnetic field or a certain kind of force which is driving or which is attracting the other object towards it. So in this way, students, there are contact, action and distance forces, and the representation of force is represented by a line. Thank you, students. Thank you very much.